Do people really use Metacircular evaluators? Hello, my name is Eric Normand, and I help people thrive with functional programming. So this is from a listener question on one of the previous episodes. Very good question. This listener, they were reading Structure and Interpretation of Computer Programs and was wondering about whether in the real world, not in academic texts trying to teach Lisp and programming, in the real world, do we use the Metacircular evaluator? It's a really good question. And so in order to answer it, I'm going to have to kind of go back and explain what the book is doing, just so that all of us can understand the answer. Okay, so in the book, Structure and Interpretation of Computer Programs, I'm probably also going to call it SICP a little bit. That's the abbreviation, SICP. There is an implementation of a scheme interpreter written in Scheme. Okay, so you write an interpreter for Scheme in Scheme, and then in the next chapter you actually take that and turn it into a compiler, which is pretty cool. You're compiling Scheme to Scheme. Now, why would you do that? A couple of reasons. One is that Scheme was designed as a language to explore programming language semantics. So when you write your new Scheme interpreter in Scheme, you're able to change the semantics of Scheme a little bit. So you could add, instead of call by value, because functions are called by value in Scheme, meaning if you do plus a b, it takes the value of a and the value of b and passes it to the plus. But you could change it to call by name, so that the variable a is passed in, and so then the plus function or whatever function could actually modify it or access it later, or maybe it accesses it lazily, like it might never need to do that. And so there you can play with the semantics of how the interpreter works, and how the language itself works. And that was the original design. Okay. The second reason why you can infer why they did that is that the original Lisp was defined in terms of itself. So it's kind of a tradition that these Lisps, and Scheme is one of them, can interpret themselves, right? That you're operating on code which is represented as data, and so you could write a function that's an interpreter, and you're off to the races. Okay, and in the in that chapter, the interpreter is called the Metacircular evaluator. It's a bad name. Okay, it's too confusing what it means, because it doesn't mean much. Metacircular, what does that mean? Evaluator is fine. Instead of an interpreter, it's called an evaluator. It just means it evaluates it to a certain value, a fixed value. It takes some expression and it evaluates it. You get the number 5, right? Okay, but the Metacircular part is confusing because it's written in itself, and that seems kind of cool. A lot of people incorrectly understand, they incorrectly interpret that Metacircular means it's written in itself. So Metacircular does not mean it's Scheme written in Scheme, or it's Clojure written in Clojure, it's Haskell written in Haskell. That's not what Metacircular means. What they mean in the book is that it's written with 2 mutually recursive functions. So there's the eval function. That's the main evaluator function. It takes an expression and an environment, and it evaluates the expression. Apply is the other function. So when, a lot of the types of expressions you have in Scheme are just handled in a big if statement in your evaluator. But when you get to functions, you need to apply the function. And so there's a function called apply that takes the function and a list of arguments and applies the function to it. Okay, so eval will call apply. But if you look at the definition of apply, it is defined in terms of eval, because there's code in that function that now needs to be evaled, right? So it's mutually recursive, which I think is a better name for this. Instead of metacircular, it should be called mutually recursive evaluator. And then it's not as cool because it's already recursive. Eval is already calling eval. But it's also calling apply, which is calling eval. And they thought it was kind of cool and whimsical. There's diagrams with a yin yang symbol and eval on one side. Eval is the yin and apply is the yang, and they're calling each other in this circle, and at some point they're going to bottom out and hit a value that doesn't need to be applied. And it's a little cute, let me put it that way. So it's the idea of naming it something and calling out this idea that it's mutually recursive is not that interesting. Okay, so back to the question. Do people really use this kind of interpreter in real work? And I would say yes, in more advanced code, so code written by more advanced programmers. I have seen this in the real world. Very much so. They're not writing closure in closure or Haskell in Haskell or what have you, JavaScript in JavaScript. They're not doing that. But they are interpreting data using a recursive, it's recursive data. It's being interpreted, and the interpretation is complex enough that it is no longer a simple state machine, right? It's moved on to the level of needing a stack, or it's being Turing complete almost, like it has an infinite tape, and it's recursive. So the interpreter, the language is recursive, the data structure is recursive, and so the interpreter has to be recursive, and often it will have mutual recursion because there's the nesting of things. Function calls are just nested expressions, right? That are happen to be defined elsewhere. It's some subroutine somewhere that you're calling out to. So it's a call out there, but then it's just more code that needs to be interpreted. So it's got that mutual nature that they were trying to call out with the name Metacircular interpreter. So yes, I actually read a book recently called Algebra-Driven Design. It uses Haskell as the language, and they develop a grammar, a sort of DSL for writing, for drawing graphics in an MC Escher style, which actually comes from structure and interpretation of computer programs as well, and probably had its roots before then. But in structure and interpretation of computer programs, they just write the functions that do it. right? So you can build up these layers of functions that operate on pictures, that copy them and mirror them and put them side by side and things like that. And you can make these cool MC Escher style pictures. Well, in this book, instead of writing the functions that do that, they write an interpreter for a minimal language that can represent these. And it has the same effect. The only difference is that you have this data representation of all of the operations, all of the mirror and the rotate and those kinds of things get represented in a data structure, and then that data structure is interpreted into and by the way, the data structure is normalized, right? So then it gets interpreted by this interpreter, and then you can rasterize it and draw it on the screen, which is pretty cool. And they were suggesting this technique because it lets you define that like minimal set and operate as an interpreter would. There's room to add like optimization steps and other things that you can't get when you're working in functions, which are purely opaque. Like you're operating on this function that's going to return an image when you call it, but you can't know, like, well, if I rotate it 4 times, that's really the same as not rotating it, so I can't optimize that away. It's going to rotate it 4 times because it's just a function. It's totally opaque. So anyway, yes, we do use it, and the complexity of the language is going to determine how complex your interpreter, your evaluator actually needs to be. You want to keep your evaluator simple. Often you can handle it with just a simple state machine, but if you've got a recursive language, if you've got a recursive, expressions, then you're probably going to need a recursive one. And then if you got these nested things, like a function is, then yeah, you're going to have a metacircular one, a mutually recursive one. All right. If you like this episode, please give me more questions so I can answer them. This is a cool one. I've actually got a backlog of questions. I've been kind of not able to record as much as I'd like. But still, I love all these questions. You can find this episode at lispcast.com/podcast. You can subscribe. You can find me on social media there, and also my email if you want to send me a question. And yeah, I'm just gonna end it there. My name is Eric Normand. This has been my thought on functional programming. Thank you for listening, and see you next time.